Welcome. My name is Chris Madden. I'm a solution architect at NetApp. Been there for 14 years. For those who don't know NetApp, we're a data management company. I used to say we're a storage company, but we're not anymore. So it used to be we really sold probably the filers. I'm sure you guys have those, have seen them in your environments over the years, right? We used to sell appliances only. Today we sell a lot more. We sell appliances. We also sell software versions that run as virtual machines, and we also sell them that run in the cloud at Azure and Amazon. So we have a very broad portfolio. So today I have a couple of, two presentations actually, that talk about some of the solutions that we help enable in the market. Maybe give you some ideas on how you can progress your environment. So the first topic we have here is about OpenStack, and it's quite a mouthful. You'll see, OpenStack, Sahara, Manila, and Analytics, and NFS, right? A lot of things here. So I thought first we'd say a little bit about OpenStack. So how many people in here are using OpenStack today? Great, so maybe about a half, maybe a third to a half. So OpenStack is a solution, right, that lets you essentially build a cloud yourself. So do what the Amazon and the Azures are doing, but do that yourself with your equipment and offer services up to either internal customers, external customers, right, many different folks. The OpenStack project or family, let's say, includes many projects. And these projects are very diverse. And they all have crazy names. And if you're not part of OpenStack and familiar with that, you probably won't know what these names are. But there are things about, virtual machine as a service, block storage as a service, file shares as a service, right? Lots of different things. And the ones in blue here are, let's say, the core ones. And there are a whole bunch of other ones. Now today I'm going to talk about these two in red here, the Sahara service and the Manila service. And maybe for a little bit of context, the Manila service, I'll just give you a little spoiler, it's actually a shared file service. So how you manage shared file services in an OpenStack environment. And the reason why that's an important or interesting project is, in fact, IDC, one of the analyst firms out there, they say that around 65% of all storage that's sold is sold for shared file systems. So not for dedicated storage use like in your laptop, but made for something that has on top of it some kind of a shared file system. Now, of course, the most common ones you see in a distributed open systems environment are NFS and CIFS, or SMB is actually probably the better name. But a lot of other ones, right? GlusterFS, HDFS. We saw earlier today, other ones that CERN is using. There are tons of shared file systems out there. Now, if this is a huge demand, you can then imagine that OpenStack environment, you'd want to also access shared data. So how do you do that? And that's kind of where the Manila project came about. So the Manila project allows for different shared file system drivers to be managed underneath that OpenStack umbrella. And if we look, there are a variety of drivers that are available today, and you can kind of see how popular they are. One thing I would note here is NetApp is popular because we have a lot of NFS installed base. A lot of people use NFS storage, wanted that available in the cloud. So they use it. We also see a lot of HDFS is used. So that tells me as well people are doing analytics as well in the cloud, right? They're interested to use their OpenStack cloud for running analytics. From an investment perspective, NetApp is very active in this community. So actually, the Manila code is, we're the largest single contributor for that. So we kind of contributed that to the community to give this shared storage access to OpenStack, along with many others. It's, of course, not an exclusive, something we did exclusively, but we're spearheaded it. If we look at what Manila is then, this project within the overall OpenStack family, it's delivering this file systems as a service. So I mentioned it's really the control plane. The data plane, you see a couple of them there, NFS, CIFS, right? Those are a large variety of them. Manila is really focusing on the control plane. How do I allocate storage? How do I provision it? How do I ensure access control? How do I know what storage is being consumed by what other resources in OpenStack? This is something that came available in the Liberty release. So that's a code name for one of the releases of OpenStack. It's a couple of years ago now, so it's out there. And a little diagram here that kind of shows you what it looks like. Is I have here some VMs. So these are using the Nova service. So I have some VMs, and these VMs needed access to shared data. So you can see maybe 2 of the VMs needed access to some R&D data, and 2 other ones needed access to the engineering data. This works quite well. Yeah, it's a very, very popular project. I see some of my customers that have been very successful with this are doing things like database consolidation. So maybe you have hundreds of Oracle databases or MySQL databases, and you want to run these on your OpenStack cloud, and you want to ease the management. You want to have a single control plane where you can programmatically provision your compute, but also your storage. And in that case, the sharing of storage via NFS and the benefits it provides are a reason a lot of my customers are choosing for this kind of architecture. Customers also, though, want to start doing analytics processing on their OpenStack cloud. And maybe the most popular analytics platform out there is Hadoop. But it's really the same for Spark, Storm, right? Some of the other projects. And one of the first things you'll discover if you try to implement one of these is that they're not especially easy. They do take some expertise and some training, some time in the trenches to make them work. They're also typically using physical hardware. So you now have to manage the physical hardware, manage failures of it. You need to do more investment of your time and energy in order to size and create this stack that's going to be dedicated for your analytics processing. Meanwhile, the users are doing different things every day. So their demands may be increasing or decreasing if they decide to adopt other technologies. So building a static infrastructure can be a challenge, right? Building a physical infrastructure for Hadoop can be a challenge. Kind of last there, also if you want a development environment, well, that's also going to be a pretty expensive proposition. So this was seen in the market, and this is actually where Sahara was invented. So Sahara is a project within OpenStack that's focused on bringing data processing as a service, so analytics as a service, basically allowing you to take Hadoop and put that on your OpenStack cloud. So this gives you interfaces, again, gives you the control plane in order to easily and quickly provision up Hadoop clusters or data processing clusters. Makes it much easier and scalable and simpler. It has a lot of defaults that allow you to get going quickly without having to know a lot of details. There's a lot of sane defaults, but also allows you to get your hands dirty if you want. So in this diagram here, it's just showing an example environment where someone's using Manila with some NetApp NFS-based storage to provide some shares. And we see a 4-node Hadoop cluster that has been, or Spark cluster rather, that has been spun up by Sahara and is a managed service underneath Sahara. So if you look at then a little bit more detail about how Sahara is working, Sahara needs to access shared storage, yeah, because it needs to access storage for these analytic jobs. And I thought I would briefly talk on 3 different possibilities that are there. There are actually even more possibilities, but these are 3 of the most popular. So the first one on the left here is showing how you can access external HDFS storage. So if you already have an HDFS cluster, this cluster can be added into the Manila service as a backend, a storage backend. And then as you provision your data processing clusters, you can also make use of your HDFS storage. You don't have to do it separately as a separate task. It's embedded into the workflow. In the middle one, this one I think is quite interesting. It's actually using the NFS service that we already have as part of Manila, so the ability to manage NFS shares. And then it's adding to that this NetApp Hadoop NFS connector. So what this connector is it allows you, it exposes an HDFS compatible interface that's actually backended by NFS. So if you think of some of the benefits that might bring to you, if you already have an NFS-based environment, you already have data on that system that you want to analyze, you don't have to bring that data into an HDFS infrastructure, use it, export it back out to your NFS infrastructure. you can do the analysis you want natively in place on the NFS infrastructure. And you can do that managed by the Manila and the Sahara service. So it could be very interesting for a lot of workflows. The final choice you have that's also popular is actually using a local volume that's backed by a storage that's provided by the Manila service. So you can almost think of kind of as a caching layer. It's sitting in front of a backing service. So in a very short period of time, right, all these sessions are very quick, what I kind of wanted to introduce you was really these main points. So first, that OpenStack has this file sharing service. File sharing service is called Manila, and it's there making shared file services available to the rest of the OpenStack infrastructure. That if we then add on top of that Sahara, we can use Sahara to manage our analytics as a service, and it can take advantage of our file shares that are presented in order to have that storage persistency we want. We can also add to this the NFS connector that is available on GitHub. So this NetApp NFS connector that allows you to make use of the NFS storage natively in your Hadoop jobs. And if you kind of combine all that together, it gives you a pretty easy, pretty straightforward, as easy and straightforward as it can be, analytics infrastructure that you can use in your environment. So if you're already using OpenStack and you already have NFS-based storage, it's quite easy for you to stand up an analytics infrastructure and offer that as a service to your end users. There are a variety of resources here that you can take a look at after the session here. And we'll also be available later in the break to answer any questions you might have out in the atrium area.
Thank you. Thank you very much. Definitely I have time for a couple of questions, while also the next talk is with you or is with your colleague?
Yes. So actually my colleague was supposed to be here today and was unavailable to be here at the last minute.
Okay.
So I have actually two today.
Okay, so do you prefer to switch over immediately, or you start getting questions on this?
If we have a question here, we can take it. Otherwise, we can switch to the next session.
Well, while maybe somebody think to a question. So if I would like to use a Sahara, so this is, is on top of Manila, or is it completely independent?
No, so Sahara and Manila are independent projects within OpenStack. So it's really Manila is giving that shared file service, so making your basically shares or any kind of, it's a control plane for shared storage to the rest of the OpenStack ecosystem. And Sahara is okay, now if we have a specific use case of big data processing, how can I enable that on my OpenStack cloud easily? And as many of the OpenStack projects, they all kind of, can rely on each other. Sometimes they depend on each other, and sometimes they can be used together. And this combination here is kind of using them together to make an infrastructure that's easy and quick to get online and offer benefits to the end users.
Okay, thanks.